All right, so here's the question from the My Open Math Lab. It is from section 2.3, it's number 15. And it says here that we want to find the volume when the region is bounded by the parabola y equals 4 minus x squared and the line y equals 3 is rotated about the x-axis. So the first thing when we approach these problems that we should do is take a look at what this looks like on the graph. So let's grab a calculator and let's graph it. So here's my calculator, and I'm going to plot my parabola. One minus x squared. And then I'm going to plot the horizontal line y equals 3. And I'm going to hit the graph button. I may have to adjust my window. In this case, I don't. This is just a standard viewing window. And so we're talking about this tiny piece here. And so I need to find where these intersect here, where the two graphs intersect. And I could do that by setting them equal to each other and solving. Or I can also sometimes take a look at the table. So I could use the table, and I can see that at -1, they both have the same y value. And also at +1, they both have the same y value. So that's the intersection point. I can also use the calculator, so I'm trying to show you a few different ways. And I can hit number 5, intersect. So second trace, number 5. And then it asks us which two lines are we talking about. So we'll say yes to this. Then it flips down to the red line. We say yes to that. And then it says take a guess. So put your cursor nearby, and then it gives you the intersection point. You can repeat that process for the other side. Now, also, let me zoom this in a little bit so we can see it a little better or clearer. I will change the y minimum and x minimum and max, and the y minimum and max to look like this. And so now when I hit graph, I can see a little clearer. And so when I do that second trace and go to number 5, I can see the other side. Again, it'll ask me first curve that I'm talking about, yes, second curve, and then I'll put my cursor nearby. It doesn't have to be precise, just near it so it knows which intersection point you're talking about. And here I have 1, 3 also. So it's this little piece here. I'm going to draw it on my paper here so that we can take a look at what we're talking about. So here is my XY plane. Oops. Didn't mean to go so crooked. Let's erase that. And so something like this. And I've got a parabola. The parabola is at 4. It opens downward, has a y-intercept at 4. And then I've got the horizontal line at y equals 3. So this point here would be 1, +3. And this point here would be -1, +3. And so it's this tiny piece in green. So I want that region that's bounded by these two graphs rotating around the x-axis. So take a look at our book. Now, if you go to the My Open Math, I'll show you how to find this. Let me grab the book. So I'm in the section that we're discussing, this 2.3, and I'm going to hit the read volumes here. And so this will pull up the book, and then you open the appropriate chapter. So here's chapter 2, going to go down to 2.3, and then this will talk all about the different ways to calculate the volume. So I'm going to scroll down to this portion here, and because I'm in this section, we talk about the disk method, the washer method, the shell method, and so it talks about which method should you choose, comparing the different methods. So this particular one, if we look at the graph, when we rotate that, we visualize the rotation around the x-axis. The washer method is going to be our best method to choose because of the cavity in the center. Now you could also use a shell method because it's with or without a cavity in the center. But this is the one that I want to choose because I want to do the vertical rectangles. This is the x-axis rotation. So that shell method would be more difficult to do. So we're going to use the washer method, and we're going to visualize it's this piece that is rotating around. So here we have the washer method. Let's go back to our paper. And so I'm going to write that washer method down. And is the volume is equal to the interval from A to B of pi, and then we've got f of x squared minus g of x squared dx. And so which one is f of x, which one is g of x? Well, f of x is the top function here. This top function was my 4 minus x squared. So we're going to call that f of x. And the bottom function is my g of x, and my bottom function was 3, y equals 3. So those are the two ones we're going to use. So we're going to plug those in there. My a to b is the would be -1 to positive. So because those are the two intersection points there. Now again, I showed you how to do it on the graph of intersection points. You can also do it algebraically if you set the two functions equal to each other like this. 4 minus x squared equals 3. And then you solve for x, you're going to get plus or minus 1. And so those are the two intersection points. So you can find those, like I said, with the calculator using the table. You can use that intersection tool on the calculator, or you can set them equal to each other like this and solve. So 3 different ways you could do that. But now we have those intersection points, so we're going to put them here. So from -1 to 1, and then let's plug in f of x and g of x. So we've got 4 minus x squared minus 3 squared. So let's do some algebra here. This 4 minus x squared, that is going to be, now remember, what do you have to do here? Not just squaring the 4 and squaring the x squared. You have to remember you have to use the FOIL here. So it's actually this, right? So don't make a mistake because that could lead to an error. So you want 16 minus 4x squared minus 4x squared, and then minus x to the 4th. So you actually get this when you square that, and then 3 squared is 9. So now let's continue. Let's clean this up a little bit before we integrate. So it's from -1 to 1, and then we've got 16 minus 9 is 7, minus 8x squared minus x to the 4th. And so I'm going to integrate this, and I'm going to get 7x minus 8x cubed over 3 minus x to the 5th over 5. And that's going to be from -1 to 1. So now when we evaluate this integral, let's see what we get. So get this pi outside here, and then I'm going to get 7 minus 8/3 plus 1/5 minus that's -1 times 7, so it's going to be -7 plus 8/3 minus 1/5. But then I have to distribute out this negative sign to all of those, and I end up with this. And now finding the common denominator and adding all of these together, the common denominator here would be 15. So the first thing I could do is I could combine this to make my life a little bit easier. Like this. And then the common denominator of 15 would give me 14 is the same as 210 over 15. This would be 80 over 15. This would be 6 over 15. And I end up with pi times 136 over 1 over 15, which let's put that in the calculator. Let's see what we get. Oops, I put in 135 and 136. 136 pi over 15 gives me my answer of 28.48377. And that will be my answer. That's the volume of that region when you rotate it.